Hello everyone. Today we are going to do Chemistry Higher Level Paper 1, which was on 4th November. In Indian subcontinent, it was on 4th November. And this is the last paper of the old course. Since the course has been changed from 2025 onwards, so this is the last paper of the old course. And this paper has 40 questions and 40 marks, the same pattern is going from 2016, 1 hour, 40 questions. Okay. Now we are going to start with the question number 1, which is as usual the question on mole concept. Always it comes. Question is, how many moles of phosphate ions PO4 3 minus are there in 103.39 grams of calcium phosphate whose molar mass is 310.19. They are asking us moles of phosphate ions and the molar mass and the mass of calcium phosphate is given. So first I'll find out the moles of Ca3PO4 whole twice. Ca3PO4 whole twice moles is given mass is 103.39 upon 310.18. I am getting, it comes out to be 0.33. Okay. Now 1 mole of this calcium phosphate contains 2 mole of phosphate ions. Okay. Therefore 0.33 will contain how much? 2 into 0.33. So what's the answer? Answer is 0.67. 0.33, that is 0.67 is the answer. Okay. So the first question answer is C. Now, what is the sum of the coefficients of the balanced equation of the combustion of iron 2 sulfide using the smallest whole numbers? So we have to find out the sum of the whole numbers. Since FeS, O2, Fe2O3 and 4SO2. If I put 2 here, I think it will be 4Fe. And then if I put a 4, then the iron is balanced. Oxygen and sulfur. Sulfur is 4. So I have to put a 4 here. Then oxygen is 8 and 6, 14. I'll put 7. So sum is 4 plus 7 plus 2 plus 4. 4 plus 7 plus 2 4 is 17. Answer is 17, the D. The second answer is D. What is the yield of sodium chloride? Next is yield of sodium chloride in grams. When 4.60 sodium reacts with 1.14 dm cube of chlorine get STP. And molar volume given is 22.7. According to this equation, 2 moles of sodium reacts with 1 mole of chlorine. 2 moles of sodium reacting with 1 moles of chlorine to form 2 moles of sodium chloride. The mass is 4.60. Moles is 4.60 divided by molar mass of sodium, 23. Moles of sodium is 4.60 upon 23. And the moles of chlorine, we know 1 mole of a gas at STP is 22.7. Therefore, how many moles is, if you want to find out the moles from the volume given, it is 1.14 divided by 22.7. Okay, so this will give you the moles, 22.7, 1.14 divided by 22.7. This will be the moles of chlorine, 1.14 divided by 22.7. Now LR, if I want to find out the limiting reagent, why I am finding a limiting reagent here? Because both the reactants I have the masses or the moles, and LR will be 4.60 upon 23 divided by 4.60 upon 23, 0.2. 0.2 divided by 2, and this will be 1.14 divided by 0.05 divided by 1. So it comes out to be 0.1 and it is 0.05. Okay, it means chlorine is my LR, and according to this equation, 2 chlorine is my LR. According to this equation, 1 mole of chlorine, 1 mole of Cl2 give me 2 moles of NaCl. 2 mole of NaCl. Thus 0.05 will give you 0.05 into 2 moles of NaCl, that is 0.1 mole of NaCl, and the NaCl mass is 58.5. Therefore the mass of 58.5 into 0.1, that is 5.85 approximately. That will be the mass of NaCl produced. Answer is C. Okay. First I find out the moles. This gives you the moles, and then LR, and by using the moles of LR, this is my chlorine is my Lr. By using the moles of Lr, I find it out the moles of NaCl produced. What is the pressure in pascals? I have to calculate the pressure in pascals. And in a 3 dm cube cylinder, volume is 3 dm cube containing 64 grams of oxygen at 25 degrees Celsius, and R is 8.314. 25 degrees Celsius, we should convert this temperature to Kelvin, and it will be 298 Kelvin. The moles of this oxygen will be 64 upon 32, that is equals to 2. Volume in dm cube, since I want to find out the pressure in pascals, I have to convert volume to meter cube. 3 into 10 to the power minus 3 meter cube. This is my volume. Therefore, R equals to 8.314 and P equals to nRT upon V. Therefore, P equals to N is 2 into R is 8.314 into temperature 298 upon volume 3 into 10 to the power minus 3. That will give you pressure in pascals. The answer is 3 into 10 minus 3. Answer is B. B is the answer for question number 4. Okay. Question 5. What is the AR of the element determined from its mass spectrum below? What is the AR of the element determined from its mass spectrum below? He's asking the AR of this. Now, what is given to us? It is given 80.1% abundance and 19.9% abundance. 80.1 for 10 and 19.9 for 11. Therefore, the atomic that is the AR is the atomic. What is the AR of the element determined from its mass spectrum? I want to find out its atomic mass. Then it will be 80.1 into 10 plus 19.9 into 11 divided by 100. 80.1 into 10 plus 19.9 into 11 upon 100, that comes out to be, that will be 80.1 into 10 is 801 plus 19.9 into 11 is 218.9 divided by 100, that equals to plus 2801, it is equals to 1019.9 divided by 100, that comes out to be 10.19, which is approximately 10.2. Answer is B. Okay, the percentage abundance multiplied by the mass EM, that is 80.1 into 10 plus 19.9 upon into 11 upon 100 equals to the AR. AR will be equals to 10.19, that is 10.2, approximately 10.2. This is the answer. For fifth question, answer is B. Next, what is correct for the wavelength and the energy of the radiations? Wavelength and energy, we have to find out wavelength and energy of the radiations of UV and visible region of electromagnetic spectrum. When I see VIBGYOR, VIBGYOR, here is IR and here is UV. Okay, as I'm moving from violet to red, wavelength is increasing, energy is decreasing, UV to IR. If I'm moving from UV to IR, if I take it completely, if I'm moving from UV to IR, the lambda is increasing and energy is decreasing because energy is inversely proportional to wavelength. Okay, it means UV will have lower lambda and higher energy as compared to visible region. This is my visible region. It will have higher lambda and lower energy. Okay, the answer is lower wavelength and higher energy. Higher wavelength and lower energy. Okay, that should be the answer. Answer is A. Sixth question, answer first 10 ionization energy of element. What is given us? He has given us first 10 ionization energy of an element, and this element has a 1, 2, 3, 4, 5, 6. This is the ionization energy. It is increasing and then increasing and then increasing, and there's a rapid increase and then increases. This is increase in the ionization energy. We can see here, if you see here, from electron number 5 to electron number 6, 4, 5 and 6. From 1 to 4, if I see, the increase is there. 1 to 4, the increase is there. A steady increase is there. Increase is taking off, ionization energy is there, and ionization energy is increasing. After 4, the energy is slightly more, increase is higher, and then so I can see clearly the increase between 4 and 5th is slightly higher, and from 1 to 4 it is a steady increase. Ionization energy is increasing, and after 6 there is a very rapid increase or very high increase of ionization energy. It means these 4 electrons could be in same subshell, these 2 in another subshell. If I determine these could be 4 on the same subshell, next 2 on the next subshell, and then next 4 in the other shell. Shell is changing here. So what is the element we have to find out? Chlorine. Chlorine configuration is 1s2, 2s2, 2p6, 3s2 and 3p5. This is the configuration of chlorine. So we can see there are 7 electrons in same shell, but I have 6 electrons in the same shell, therefore it is not possible. Chlorine cannot be the answer. These 7 electrons should have almost same energy or slightly increase in energy. Chlorine cannot be my answer. Chlorine is not possible. Next, neon has only 10 electrons and we have 11 electrons, 10 electrons here. Neon is at 10 electrons. Configuration is 1s2, 2s2, 2p6. This is the configuration of neon. It has 10 electrons, total 10. The energy of the first 2, and if I see the first 6 electrons, that is the 2p6, should have almost same energy, but we are observing that after that the next 2, that is 2s, they should have higher energy, but we can see the next 4 have energy. Energy goes on increasing. There is increase in energy, so I think neon is also cannot be the answer. Now comes oxygen. Oxygen is 1s2, 2s2, 2p4. Oxygen has total 8 electrons only and we have 10 electrons. Oxygen also not possible. Now next comes sulfur. 1s2, 2s2, 2p6, 3s2, 3p4. Now if I see sulfur, the first 4 electrons, they are removed from the p subshell. Thus I can say these are the first 4 electrons, the 1, 2, 3, 4. These 4 are lost from the p subshell and the energy is increasing. Next 2, they are lost from the s subshell of the same shell. Next 2 are lost from s subshell of the same shell. Same shell, s subshell, they are losing next electrons. The next 2, they are lost from this subshell. Next 2 are these 2. So they can be lost from 3s and their energy is slightly increasing. They are lost from these 2, 4 are lost from 3p. Absolutely correct. And then a new shell comes which is 2p6. Then the new shell comes. The energy is very high. So the answer could be D. D is the most probable, that is S, sulfur. Sulfur is the most probable answer for this. Chlorine is not possible. Neon has only 10 electrons. Out of this, 6 should have same energy, not possible. And then oxygen has only 8 electrons, not possible. Hence my answer is D, sulfur. Okay. Now 8th question. Question 8 says hexa aqua cobalt. The name of this compound is hexa aqua cobalt. Hexa aqua. Aqua is for water. Cobalt. And cobalt 3, and this is an ion. This is the name of this compound. Is blue in color. Hexa is for 6, blue in color, whereas hexacyanocobaltate is pale yellow in color. The name is not in the course. I want this color only. Is blue in color, whereas pale yellow in color. Which statement correctly explains the difference in color? Now these two have different colors. Reason is both have cobalt as a CMI, central metal ion, but the ligands are different. Both have different ligands. Water and cyanide, they are different ligands. Now if I see my data, if I see this question, then both are octahedral because they have 6 ligands. Both have 6 ligands. The charge of cobalt in both is +3. Oxidation state is also +3. So they have same oxidation state, same central metal ion, but they differ in ligands. Ligands are different. Now the ligand, in ligand CON6 is a weaker and absorbs lighter of higher frequency. Since CON6 is pale yellow in color, it means it is absorbing light of pale yellow color, it is absorbing light of lower frequency. COCN6 is weaker and absorbs light of higher frequency. It is wrong. Since it is cyanide ion, it should absorb light of higher frequency because it is a strong field ligand. It is not a weaker ligand, it's a strong field ligand. It's wrong. Oxidation state of cobalt is different in each complex is also wrong. Oxidation state is same. Different colors are due to the different charge on the complex ion. The charge on the complex ion is same, it's also wrong. Charge on the complex ion. If I see the charge, it's 3 minus and 3 plus, so this also does not control the color. Charge on complex ion do not control the color. Now, next is the ligand CON6 causes a larger d orbital splitting and absorbs light of higher frequency. Now we know CN is one is called as a weak field ligand, is called as a strong field ligand. CN is a strong field ligand. Cyanide is a strong field ligand as compared to water, which is a weak field ligand as compared to cyanide. Weak field ligand. Okay. Now, when a weak field ligand and a strong field ligand, they are present in a compound. A strong field ligand has higher repulsion between the electrons of d orbitals in the ligand, hence higher CFSE crystal field splitting energy. D orbital splits more here, d orbital splits less here, lesser splitting. It will be lesser splitting. So it will have higher splitting. It means it is higher splitting is there. When higher splitting is there, CFSE is higher. It requires a light of higher frequency. Higher frequency is required for DD transition, and it requires light of lower frequency. Therefore, absorbs light of higher frequency. Hence, my answer D is the correct answer because all other options are wrong. CN is a weaker ligand, wrong. It absorbs light of higher frequency. It's a weaker ligand, cannot absorb light of higher frequency, wrong. Oxidation state is different in each complex, wrong. Different colors are due to different charges on the complex ion. Charges on complex ion do not control the color, is also wrong. Answer is option is D. Next question, question number 9. Which of these period 3 oxides form a solution with pH less than 7? I want pH less than 7. It means it should be acidic in nature. This shows pH less than 7 when added to water. So these oxides should be acidic in nature. Okay. Al2O3, it is an amphoteric oxide. It can react with acid and base both. MgO is a basic oxide, forms MgOH all twice. pH NaOH is also basic. NaOH banayega, it forms NaOH. And P4O6 is phosphorus. P4O6 is phosphor trioxide. It reacts with water to form S3PO3. And S3PO3 is an acid, therefore its pH will be less than 7. But therefore my answer is D. Which configuration? Next question, question 10. Answer for question 9 is D. P4O6, phosphorus trioxide, which forms phosphoric acid, which is acidic in nature. Hence pH will be less than 7. Which configuration is that of transition metal? Next question, question 10. Which configuration is that of transition metal atom in the ground state? I want transition metal atom in ground state. So what should be transition metal? It should have d orbitals incompletely filled, and ground state, that is 4s, should be completely filled. Neon 3s2 3p6 cannot be a transition metal. Ar3d9, where is 4s? There is no 4s, hence also not transition metal. It is in excited state of transition metal. Now next is 1s2 2s2 2p6 3s2 3p6 4s2 3d10 4p2. Last electron going in the p subshell, also not transition metal. And answer D is 4s1 3d5, which is the configuration of chromium ground state. This is my answer. So the chromium is a transition metal, and we have ground state configuration of chromium. Hence answer is for D. 10 is D. For 10 also the answer is D. Next, which type of intermolecular forces? Question 11. Intermolecular forces. Intermolecular forces exist between methane, CH3OH and CHCl3 molecule. Methane is non-polar, as we know. It is non-polar. CH3OH is a hydrogen bonded molecule, and CH3Cl is a polar, because the C and Cl, they have different polarity, different electronegativity. A polar molecule has dipole-dipole interactions, dipole-dipole, as well as London forces. Both are present in a polar molecule. Hydrogen bonded molecule have London forces, hydrogen bond, as well as dipole-dipole interaction, whereas a non-polar molecule only has London force. So these are the forces which are present. Let us check. London dispersion only. It is CH4, it's correct. Methanol, it is London dispersion, hydrogen bonding and dipole double, all three correct. CH3Cl, London dispersion and dipole double, correct. It means all the three are correct. Answer is A. Answer should be A. If you want to go to next option, you can see London dispersion, hydrogen bonding not present. London dispersion only present. London dispersion and dipole in this methanol. There should hydrogen bonding also, therefore it is incorrect. London dispersion hydrogen bonding incorrect. It means my option A is 100% correct. Clear? Next, what is the molecular geometry and hybridization of the numbered? We have to find out the molecular geometry and hybridization of the numbered atoms in the molecule given shown below. Numbered atom means the atom number 1, atom number 2 and atom number 3. First we talk about atom number 1. The hydrogen is in the nitrogen atom is a lone pair and a double bonds and single bond. When a lone pair, double bond and single bond is present, lone pair, double bond, single bond, the hybridization is sp2 hybridization, and the shape is converted to band. It has a band shape. Okay, nitrogen has an sp2 hybridization and a band shape N1. Next, if I talk about atom number 2, which is a carbon here, and this is double bonded, carbon is the double bonded carbon, so it will have a trigonal planar and sp2. It is also sp2. And next is this carbon number 3 here. Carbon in 3 here is bonded by triple bond, therefore it should be sp hybridization. So this is sp2, nitrogen 1, then again sp2 carbon, and then sp carbon. This carbon is sp2, this carbon is sp, and this nitrogen is sp2. sp2 with a lone pair is a band shape. sp2 simple sp2 is trigonal planar, and sp is always a linear molecule. Therefore my option is sp2 band, and then for nitrogen sp2 band is here, and for carbon sp2 trigonal planar, correct, and for carbon 3 it is sp linear, correct. It means my answer A is correct. Okay, next question 13. Now question 13 says, how many sigma and pi bonds are present in a molecule given below? First we have to draw the structure of this molecule. These two C, these two are the C, and they have two CN groups on their both side. Each have two CN group. This has one CN here, one CN here. This compound also has one CN here and one C triple bond here and here. Now if I see the valency of the central carbon is not fulfilled, so I have a double bond here also. You want to find out sigma bonds are always single bonds. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. So there are 9 sigma bonds. Now pi bonds 2 and 2 here, 4, 1 here 5, 2 here 7 and 2 here 9. So there are 9 sigma and 9 pi bonds. Answer is C, 9 sigma and 9 pi bonds. Answer is C. Next, which statements are correct for alloys? Question 14. Which statements are correct for alloys? Which statements are correct for alloys? The statement number 1 is the mixture of metallic. Statement number 1 says the mixture of metallic cations of different sizes increases the strength of the non-directional metallic bonding, making the alloy harder than the parent metal. Metallic cations of different sizes increase the strength of the non-directional metallic bond. When we mix alloys, they have almost same size but not exactly same. So where they have almost same size. So when they are almost same size, it means they are slightly different. When the slight is slightly different, the strength of the non-directional metallic bond increases the strength of non-directional metallic bond due to the presence of different size cations. The slip and slide movement, they are affected, and that increases the strength of the non-metallic directional metallic bond, makes the alloy harder. So this is a correct option. That is, we can say first option is correct. A different size of atoms in alloys prevent layers of metallic cations sliding over each other easily. This is also correct. Different size of atom prevents slip and slide movements. Adding carbon to iron produces an alloy that is stronger than pure iron. Adding carbon to iron makes the alloy stronger than iron. Yes, when we add carbon to iron, the alloy becomes stronger, the steel is stronger than iron. I think that option 3 is also correct. Mixture of metallic cations of different sizes increase the strength of the metallic bond. Strength of non-direct metallic bonding making the alloy harder than the parent metal. Yes, alloys are harder than the parent metal. So all the three options are correct. Answer is D. Okay, now the next question is question 15, and this question is on thermochemistry. Question is, what are the signs of delta H and delta S, that is enthalpy and entropy, for the reaction that is non-spontaneous at high temperature? Non-spontaneous at, it is exothermic in nature. This hint tells us that the reaction is exothermic in nature because it is becoming non-spontaneous at high temperature, and all exothermic reactions become non-spontaneous at high temperatures and spontaneous at low temperature. So this gives us hint that it is a exothermic reaction, and for exothermic reaction delta H is negative. So first I got delta H is negative. The answer could be B or C. Now the next thing is, in order for a reaction to be spontaneous, delta G should be negative, and we know delta G equals to delta H minus T delta S. Delta H minus T delta S. Now delta H is my negative because it is exothermic in nature, and for making delta G to be negative, the T delta S should be, if delta S is positive, delta H is negative, T delta S should be, if delta S is negative, then this minus T delta S become positive. In order to get my delta G negative, I should keep the T delta S value low. That is, the reaction will become spontaneous at low temperature. Temperature should be low, then it will become spontaneous. It means my delta S is negative. So I got delta S negative and delta G negative. The answer should be B. Delta S and delta H negative. Okay. Next question. Consider the following equations. There are three equations given to us. H2 plus F2 gives you twice of HF. Enthalpy is minus X. C plus F2 gives you CF4. Enthalpy is minus Y. 2C plus 2H2 gives you C2H4. Enthalpy is plus Z. We have to find out what is the delta H for the reaction, and reaction C2H4 plus 6F2 gives you 2CF4 and 2HF. Okay, my reactants are C2H4 and fluorine. So C2H4 is present in the reaction number 3. In this reaction C2H4 is present, but it is a product. So what I will do, I will reverse this reaction. First reverse the equation number 3. C2H4 gives you 2C plus 2H2. I reverse the equation number 3. Then now from equation number 3, if I reverse the equation number 3, then I will get C2H4 gives you 2C plus 2H2 and delta H becomes minus Z. Okay. Now next what I am doing, now for the reactions, fluorine is my next reactant. Fluorine is present in equation number 2 and equation number 1, and the carbon are 2, and the equation which I made, there are 2 atoms of carbon, and in this only 1 mole of carbon. There are 2 moles and 1 mole. I will multiply the equation number 2 by 2 and add to this. Multiply equation 2 by 2. It will be 2C plus 4F2 gives you 2CF4. If I add it, what I will get? I will get 2C cancel. I will get C2H4 plus 4F2 gives you 2CF4 plus H2. Okay. What I done? I had multiplied the equation number 2 by 2. That will be minus 2Y. Okay. Now I require 2 more fluorine, which is present in equation number 1. Multiply the equation number 1 also by 2. So what I will get? I will get 2H2 plus 2F2 gives you 4HF. If I add these two equations, add them, this is also 2H2. So I had multiplied this equation by 2, I will get 2H2. 2H2 gone. The net equation will be C2H4 plus 6F2 gives you 2CF4 plus 4HF, which is equivalent to my equation, my aim equation. This is my aim equation. What have I done? I had multiplied the equation number 1 also by 2. It will be minus 2x, and then add all them. What is the resultant now? Resultant delta H equals to minus Z plus minus 2Y plus minus 2x The answer will be delta H equals to minus 2x minus 2y minus z. Minus 2x minus 2y and minus z is my D. Answer is D. Okay. Question number 17. Which diagram represent the Maxwell-Boltzmann equation? Maxwell-Boltzmann distribution of kinetic energy of molecules of same sample of gas at two different temperatures in which T1 and T2 is there and T1 is greater than T2. Okay. This is what they tried to confuse you. Generally T2 is greater than T1, but here they had given T1 is greater than T2. And whenever we make Maxwell-Boltzmann curve, the curve which at higher temperature curve should have lower height and more flattened. Height should be lower and more flat. Higher temperature, height should be lower, more flat. This is not possible because T1 is greater than T2 and it's not flat. T2 is lower temperature, correct, and T1 is at higher temperature, correct. It is more flat, correct. The answer could be B. If I see T2 and T1, this T2 is greater than T1, not possible. In this T1 and T2, T1 is lower temperature than T2, which is also wrong. This shows T1 is lower temperature, wrong. The answer is B. Why? Because T2 is the lower temperature whose curve is has more height and less flattened, whereas T1 is the lower temperature, the peak of the curve is below the T2 curve and it is more flat. The answer is B. 17 question, answer is B. Question is question 18, and in this question is asking you what is the enthalpy change in kilojoule per mole when 107 gram of ammonium chloride NH4Cl is added to water to form 50 centimeter cube of solution, producing a maximum decrease of 28 degrees Celsius. Temperature is decreasing means it is an endothermic reaction. My delta H should be positive. Okay. Now MR of NH4Cl is 53.5, specific heat is 4.18. We know the formula for delta H is Q upon moles. Moles of the LR or moles of the solute. Now Q is MC delta T. Q equals to MC delta T, and delta T, which is my change in temperature, is given as 28. Need not to add 273. Why? Because it is already changed, decrease in temperature. From 0 to 28 degrees Celsius, there is a decrease. What is the final temperature? It has decreased to 28. The final temperature is lower than 28 degrees Celsius, lower than the initial. When we are finding out difference, we need not to add 273. So it will be 28 delta T. C is 4.18 and the mass of solution is 50 grams because densities we are taking as 1. Thus delta H and the moles is the mass of NH4Cl given is 107. Mass is 107 and the molar mass given is 53.5. 53.5 is my molar mass and the mass is 107. Moles comes out to be 2. Thus delta H will be 50 m. C is 4.18 into delta T is 28 upon moles is 2 and we want in kilojoule divided by 1000. Thus the option which fits in this, my answer is option D. Answer will be option D for question number 18. Okay, we find out Q. It's an endothermic reaction. We first find it out the Q, and then finding out the Q, we divided the Q by moles and 1000 because we want the answer in kilojoule per mole. Question 18, answer is D. In this question, the question is the non-catalyzed decomposition of H2O2 was monitored, giving the dotted lines in the graph. Which curve represent the catalyzed reaction if performed at the same temperature? This is non-catalyzed, dotted one was non-catalyzed, and the bold one, they are catalyzed reactions. So whenever you add catalyst, the rate will increase, whereas the yield will remain same. Yield is same. That is, the reaction will complete at the same point. If this is my uncatalyzed, the answer, the rate is increasing in A and B. The answer could be A and B. A could be the answer and B could be the answer. Because in both A and B, the rate is increasing. C and D are not possible. C and D cannot be the answers because in this, the rate is not increasing, it is decreasing. In case of A, the yield is also increasing, the volume of CO2 is also increasing, which is also not possible. Hence, the answer is B. Rate is increasing, but the reaction is completing at the same point. That's the yield or the volume of oxygen gas produced will be same. For question 19, the answer is B. Question 20. The rate constant of a reaction at different temperatures are plotted giving the following graph. ln k versus 1 upon t graph is given to us. And the slope of line is ln k minus Ea RT plus ln A. The slope of the line represents, now what is asking, what is the slope of the line? ln k minus Ea upon RT plus ln A, the slope of this line, slope is always equal to the direct formula based question minus Ea upon RT. The slope of this graph is always minus Ea upon RT, therefore my answer is D. Slope of the line is minus Ea upon RT, direct question, answer is D. Question 20, answer is D. Next question 21. Reaction between carbon monoxide and nitrogen. Reaction between carbon monoxide and nitrogen dioxide is given in a two-step mechanism. The mechanism is given to us nitrogen dioxide and carbon monoxide, CO and N2. They are the NO2, they are the reactants. Step number 1 is slow and this is my RDS. Rate determining step is my RDS first, and in RDS there are 2 moles of NO2. Therefore the rate expression is R equals to K NO2 square. It is a very simple question. Order is 2. R equals to K NO2 square, order is 2, answer is A. It's a direct question. Why? Because the first step is slow and NO2 is my reactant also. Therefore I will directly use R equals to K NO2 square. Rate is R equals to K NO2 square. Question 21, answer is A. Question 22. Carbon dioxide dissolves in water as given in the equation. CO2 plus H2O gives you SCO plus SCO3 minus. Reaction is exothermic in nature in forward direction. Delta is negative. What is asking, what happens if the temperature of the aqueous solution is increased? As we know, it is an exothermic reaction. On increasing temperature, it will move backward direction. That is, CO and H2O is produced. The solubility of CO2 gas will decrease. Solubility of the CO2 gas will decrease. Thus, H3O plus ion concentration will decrease. H3O plus ion concentration will decrease. And pH will increase. That's the answer. Equilibrium will shift to the right hand side, correct? And pH will decrease, wrong. Equilibrium will shift to the right hand side and the pH will increase, yes, correct. Equilibrium will shift to the right hand side and the pH of the solution will increase. This will be the answer. For question number 22, answer is B. Question 22, answer is B. The equilibrium will shift to the right hand side and the pH will increase. Why? Because the H2 plus ion concentration is equilibrium will shift to the left hand side. It is left, not right hand side. Equilibrium will shift to the left hand side. This is my left hand side. Equilibrium will shift towards left hand side and the pH will, equilibrium will shift to the left hand side and the pH will increase. Equilibrium shift to left and the pH will increase. Now answer is C, not B. It is moving towards the left hand side, which is my reactant side, therefore the answer should be B. Next question is question 22, which says carbon dioxide dissolves in water. In the equation given below is CO2 plus H2O gives you SCO plus H3O plus HCO3 minus bicarbonate ion. Reaction is delta H is minus 19.3. It means it is an exothermic reaction. And the concept here is, for exothermic reaction, if you increase temperature, reaction moves in backward direction. Reaction shifts to left hand side. Backward means left hand side. What happens if the temperature of the reaction is increased? If I increase temperature, reaction always move towards left hand side, towards reactant side in exothermic reaction. When it is moving towards left hand side, the concentration of H2 plus ion will decrease. This concentration of H2 plus will decrease means pH will increase. If I am increasing temperature, reaction is moving in towards left hand side and pH is increasing. Reaction towards left hand side and pH increasing. Left hand towards left hand side, pH decreases. Thus the answer will be C. Reaction will move towards left hand side and the pH will increase. Answer is C. Question 22, answer is C. Next, question 23. Which of the following statement is correct for the position of equilibrium for the reaction? Delta G equals to minus RT ln K. This is given to us. It always shifts to the right when temperature is increased. Whenever we talk about reaction X forms Y, it shifts towards right means product side it is moving. And when we are increasing temperature, it is moving towards product side. It means delta G is becoming more negative. Delta G is negative as per this equation. If I increase temperature, delta G is becoming more negative. When temperature increase, delta G will become more negative. It means it will shift to the right. It is correct. Delta G is less than 0 when K is greater than 1. The value of K is greater than 1, then ln K will be, delta G will be less than 0, means delta G comes into be negative. The reaction is favored K value greater than 1. It means the concentration of product is greater than concentration of reactant. Hence products are favored over reactants. This option is also correct. Option 2 is also correct. Option 3 says delta G equals to 0, then K equals to 1, correct. The reaction will be in equilibrium. The K will be equals to 1. The concentration of reactant and product is almost same. Absolutely correct. All the three are correct. Answer will be D. Question 23, option D is the answer. Question 24. Question 24 says the pH of an aqueous solution Z is 5 and the pH of another solution X is 10. X pH is 10, Z pH is 5. pH 10, it means SO plus ion concentration equals to 10 to the power minus 10. SO plus ion concentration, and in this case 10 to the power minus 5. What is saying, what is the ratio of SO plus ion concentration of the two solutions? SO plus ion concentration of the two solutions, I want the ratio. So I will divide the smallest by 1, so it will be 10 to the power minus 10 upon 10 to the minus 10 equals to 1, and 10 to the power minus 5 upon 10 to the power minus 10 equals to 10 to the power 5. The ratio is 1:5. That is, the concentration of Z will be 1 into 10 to the power 5 times higher. Concentration of Z will be 10 to the power 5 times higher than concentration of X. Or I can say X is 10 to the power 5 times lower than Z. X is 10 to the power 5 times lower than Z. 10 to the power 5 times lower. The answer will be D only. Okay. Concentrations we had determined, and then we had find the ratio of these two. Ratio comes out to be 1:10 to the power 5. It means X is 10 to the power 5 times lower than Z. Answer is D. Question 24, answer D. Question 25. Using the data provided in the table, which of the conjugate base is stronger? For a conjugate base to be stronger, its acid should be weaker. Acid should be weaker. A weak acid forms a stronger conjugate base. And for acid to be weaker, the Ka value should be small. This should be smallest. If I see this equation, the smallest Ka value is for HClO, which is 10 to the power minus 8. This is the smallest. It means HClO is my weakest acid among all these. And when this weakest acid forms its conjugate base, that will be ClO minus. Question is, which of the conjugate base is the strongest? It's a weak acid and the conjugate base will be strong. ClO minus is the answer for question number 25. It is ClO minus. Why? Because HClO is a weak acid and ClO minus is my strong conjugate base. A weak acid always forms a strong conjugate base. This is the concept. Question 26. Consider the phosphate buffer system Na2HPO4 and NaH2PO4. Na2HPO4 is a conjugate of NaH2PO4. The relationship is of H plus ions. What is correct when a small amount of strong base is added? When a small amount of strong base is added, the H plus ions of this will react with the OH ions and they will convert into HPO4 2 minus. What is happening? H2PO4 minus will convert into HPO4 minus, HPO4 2 minus. When a base is added, it will react with H plus ions, which will be provided by NaH2PO4, and it convert into HPO4 minus. So what I can see H2PO4 minus are converting to HPO4 2 minus. The concentration of HPO4 2 minus, is increasing and H2PO4 minus is decreasing. Concentration of this is wrong. Concentration of OH will react with N to form NaOH, wrong. H2PO4 minus ion increases. No. Concentration of HPO4 2 minus increases. Yes. C is the answer. Concentration of HPO4 2 minus increases. OH will react with H2PO4 minus to form PO4. No. It is also wrong. For question 26, for the phosphate buffer system, when you add a strong base, the NaH2PO4 will convert into Na2HPO4 and the concentration of HPO4 2 minus will increase. HPO4 2 minus are my weak bases. Therefore, they will neutralize the addition of a strong base. Answer is C. Question 26, answer C. Okay, 25 centimeter cube. Question 27. 25 centimeter cube of weak base was titrated with hydrochloric acid. And we are adding hydrochloric acid in a weak base. The graph starting from around 11. And this is my neutralization point. This is your neutralization point around 25. The half neutralization will be around 12.5. Around 12.5, this is the half neutralization. This is, I think, half neutralization point. And the corresponding pH is 9. What is the pKb of the base? At half neutralization point, at this point, the pH is equal to pKa of the conjugate acid of this base. Hence, your pH is equal to 9, and at half neutralization point POH is also equals to pKb. Therefore, pKb will be equals to 14 minus 9, that is equals to 5. The answer for this question is 5. The pKb of the base is 5. At half neutralization point, the pH equals to pKa. For the conjugate base, for conjugate acid of this base, the pH will be equals to pKa. Therefore, POH equal to pKb. Hence, we can say POH will be equals to 14. pKb equals to 14 minus 9, that is equals to 5. pKb for this base will be 5. Answer is B. Answer is B for question 27. Question 28. In which reaction hydrogen act as an oxidizing agent? Oxidizing agents are those which themselves get reduced. And reduction means increase in, and hydrogen reduction means from 0, its oxidation state goes in negative. Okay, I will search for this reduction of hydrogen. N2, here oxidation state of nitrogen is 0 and it is converting to ammonia, and ammonia it contains NH3. Oxidation state of nitrogen here will be nitrogen is -3, hydrogen will be +3. From 0 to +3 it is oxidation. Here hydrogen is oxidized, not reduced. Na plus H2 again 0 converts into -1. 0 to -1. In this case, the oxidation state of nitrogen for hydrogen is changing from 0 to -1. We can say it is reduction happening here. Hence, hydrogen is acting as an oxidizing agent here. Next, Cl2 plus H2 from 0 to +1. CH2 plus H2, hydrogen from 0 to +1. In this case, carbon is a non-metal, 0 to +1. Chlorine is a non-metal, hydrogen is +1. In this case, sodium is a metal, hydrogen is -1. From 0 to -1 is changing in option B. And when 0 to -1, it means it is reduction happening. Therefore, hydrogen H2 is acting as oxidizing agent. Answer is B. Question number 28, answer is B. Here, hydrogen is acting as an oxidizing agent. Question 29. A voltaic cell is constructed from half cell using metal X and Z as electrodes. What will occur when this cell produces electricity? When the cell is producing electricity means the two electrodes are connected and the reaction is starting. When I see this equation, these are reduction potentials given of X. X is positive reduction potential and Z is my negative reduction potential. As per the concept, the electrode which has more negative value, or the lower value of E degree reduction, will act as anode. That means Z is my anode and X is my cathode. Z is anode and X is cathode. When Z is anode, loss of electron will take place at Z and electrons start moving from Z to X. This is the flow of electron. What is asking? And the current will move from X to Z. This is the flow of current. And the ions will move from X to Z through the salt bridge. Now what is asking? What will occur when the cell is producing electricity? Okay. A positive ion flows through salt bridge and through a Z cell. But always sulfate ions, if I say it's sulfate ions, the negative ions will move. So positive ions will move, it's wrong. Positive ions will not move, negative ions will move. Electrons flows from X to the Z. No electrons are moving from Z to X, wrong. The concentration of X minus 2 will increase. Now, when this reaction takes place, the X minus 2 they will accept and they will start depositing here. The concentration of X minus 2 will decrease, not increase. This is also wrong. The mass of Z electrode decreases. The mass of Z electrode decreases because Z will dissolve and convert into Z2 plus ions or Z ions, Z2 plus. Z will convert into Z2 plus. Then slowly and slowly this Z will be used up and the mass of Z electrode will decrease. Option D is the correct answer for this question. 29th, option D is the correct answer. This question 30 says, which statement is correct? We have to find out the correct statement for which both delta H and delta S are positive. Delta H positive means it's an endothermic reaction. And for endothermic reaction, in order to make the reaction positive, that is delta G should be negative. The value of delta H should be less than T delta S. T delta S should be greater. T delta S should increase. That is, we should increase temperature so that the reaction will become spontaneous. And for a spontaneous reaction, E cell, the value of E cell is positive. If I increase temperature, what will happen? The value of E cell will increase and the increase in temperature will take place. Which statement is correct for the reaction in a voltaic cell? If I increase temperature, E degree cell will increase and with an increase in temperature. Because by increasing temperature, delta G will become more negative. It means the value of E degree cell should increase. E degree cell will increase with increase in temperature. I think this is the correct option because E degree should increase. We'll see to next. E degree decrease, no. E degree cell will not change, no, wrong. E delta G is less than greater than 0 for all temperature, wrong. Thus the correct option for question 30 is A. Question 30 answer is A. Next is, which statement is correct for the value of E degree of the standard hydrogen electrode SHE? SHE is a reference electrode, and for a reference electrode the potential of SHE is taken as 0. Okay, it was determined experimentally, no. Depends on temperature, no. It is an arbitrary set, yes. The SHE value is an arbitrary set value which is taken as 0, and by the help of this value we determine the electrode potential of other unknown electrodes. It depends on E degree of second electron, no. It's a reference electrode, its potential is fixed and it's 0, it is arbitrarily set. Thus the answer for question number 31 is C. Question 31, answer C. Which of these functional groups are present in aspartame? This is a structure of aspartame given to us and they are asking which functional groups are present. First we'll identify the functional group. This is carboxylic acids. And this is amide. CONH is my amide. NH2 is 1 degree amine. And this is an ester. Rest is phenyl groups. What is options are given? Carboxyl group. Carboxyl is there. Secondary amino, no. Ether is no. Carboxyl secondary amino, ester secondary amino is not present. Ether primary amino, ether is not there. Ester primary amino and carboxyl, answer is D. Ester is there, yes. Primary amino group is there and carboxyl group is there. Question 32 answer is D. Ester group is there, primary amine group is also there and carboxyl group is there. Question 32 answer D. Next question is IPSC name of the compound. You have to write the IPSC name of the compound, and this compound is an aldehyde group and CHO is present here. This is CHO, aldehyde. Then this carbon number is 1, number 2, number 3, number 4 and number 5. This is the longest chain. This is one methyl group side chain, another methyl group side chain on the second and third carbon. 5 carbon pentenyl and second and third methyl group 2,3 dimethyl pentenyl. 2,3 dimethyl pentenyl. 2,3 dimethyl pentenyl. This is the only option. This is wrong, also wrong, butanol wrong, butanol wrong. Answer is A. For question number 33, the answer is A, 2,3 dimethyl pentenyl. It is an aldehyde containing 5 carbon chain. 2 and 3 there are side chains. 33 answer A. Question number 34. Question 34. Which of the following compounds can react with acidified potassium dichromate to give an acid? An alcohol reacts with an acidified potassium dichromate to give an acid and the alcohol should be 1 degree. So we have to identify a primary alcohol. This is a secondary alcohol, not. This is a ketone, no. This is a 1 degree alcohol, I think. Yes, correct. CH3, CH2, CH and then CH2OH and then CH2CH3. This is your compound and it has a primary alcohol 1 degree. They will form carboxylic acid 100%. This is a tertiary alcohol, I think CH3, C, OH and CH3 and CH3. This is a tertiary alcohol. So this is also wrong. Only primary alcohols gives carboxylic acid, hence answer is C. C is my primary alcohol, rest are not primary alcohols. Therefore 34th question answer is C. 34th C. Next is, how many optical isomers exist for ascorbic acid? A structure of ascorbic acid is given to us and he is asking optical isomers. For identifying optical isomers, we should look for chiral carbons or chiral centers. If I see this compound, here is a carbon atom, and on this carbon, one side OH group is present, one side this alicyclic chain is present, one side contains H and one contains CH2. It means this is my chiral carbon. This CH2 is not a chiral carbon. Why? Because it contains two hydrogen atoms which are identical. Only one chiral carbon is present in this compound, and one chiral carbon can give you two isomers. The answer should be 2. Answer is A. This ascorbic acid has one chiral carbon, which is this CH, and this CH can produce two optical isomers. Hence, how many optical isomers? Answer is 2. Question number 35, answer 2. Question 36, 2-bromo, 2-methyl-butane, which is my 3-degree halogen alkane, reacts with warm solution of NaOH to form alcohol. I am reacting with NaOH, that is a substitution is taking place, and convert it to alcohol. Okay. And since it's a 3-degree alcohol, 3-degree halogen alkane, it always gives SN1. It's a 1 degree will give you SN2. 3 degree gives SN1, and SN1 the reaction mechanism. He's asking what is the reaction mechanism and rate expression. Since it is a unimolecular reaction, the rate expression will contain only my halogen alkane. The answer will be SN1 and halogen alkane only as in the rate expression. SN1 and halogen alkane the rate expression correct. The correct option is B. SN1 why? Because it is a 3 degree halogen alkanes, and tertiary halogen alkane always give SN1. Primary gives SN2, SN1, and since it is a 3 degree giving SN1, it is a unimolecular, therefore the concentration of halogen alkane only controls the rate. Rate expression will contain only the concentration of halogen alkane. Question 36, answer is B. Question 37, which of the following compound would give an optically active compound on reacting with lithium aluminum hydride? We know it is a reducing agent, and it reduces carboxylic acids as well as carbonyl compounds to alcohols. Okay, propanol will form propane-1-ol. Propanol will form on oxidase, on this reduction will form propane-1-ol, CH3, CH2, CH2OH. It do not contain any chiral carbon. Butanol will form butane-1-ol, which also will not have a chiral carbon. Butanon will form butane-2-ol. Yes, butane-2-ol will have a chiral carbon. It's absolutely correct. It contains CH3, CH2, CH3, and this is a chiral carbon. This is my chiral carbon. It has 4 groups. Answer should be butanon. Butane-2-on, which is forming are 2 degree alcohols, and 2 degree alcohols are generally optically active. 2 degree alcohol, secondary alcohol is optically active in case of butanol 4 carbon, because it contains 4 different groups on the 4 side. Since it contains a chiral carbon, it is optically active and will form optical isomers. Answer will be 37. Answer C. Next is question 38. Which statement are correct about the molecular ion M plus in the mass spectrum? Is asking correct. M is not always the peak with highest intensity in the mass spectrum. Yes, it is correct. It is not necessary that M is always at the highest peak. It should be the highest. It is the first ion which is produced by loss of electron. Therefore, it should have the higher molar mass. Higher mass spectrum mass. It should have the higher mass. We can say fragment. It is not means it is correct. Which he is asking correct. Since it is written not always, it means correct. So this point is correct. First is correct. M is always the most stable fragment formed during electron bombardment. Since M is released by release of one electron from the neutral molecule, but it is not necessary it is the most stable. Stability depends on certain other factors also. So this is not absolutely correct. Perfectly correct. It's wrong. Next, third, the MZ ratio of the M plus ion peak gives the reactive molecular mass. Absolutely correct. MZ ratio will give you the molar mass of the compound, because M plus is only when one electron is lost and the molar mass remains same. It means 1 and 2 they are correct. He's asked us correct option. The correct option is 1 and 2 only. Answer is A. 1 and 3 they are correct. It means option number B. 1 and 3 correct is option B. Question 38, answer B. Question 39, which compounds give the following HNMR spectrum? The spectrum shows 3 lines, 3 peaks. 3 peaks or 3 lines. It means there should be, a compound should have 3 hydrogen in different environment. I have to search for 3 hydrogen environments. A compound must have 3 different hydrogen environments, then only it can form 3 peaks. In this case, example number 1, this carbon is having a CO on this, so this will form one peak. This CH3 will form another peak, and this CH2 will form another peak. There will be 3 peaks for this. Compound A will form 3 peaks. Next, we'll go to next part. We'll go compound B. Compound B will form CH3 for the 1. So this 2. Since this CH and this CH3, they are not same, then 3. This carbon is all again a different 4, and this OH 5. This form 5 peaks, wrong. So this cannot be the answer. Compound C, this CH3 has an environment of CH2, it will form 1, and this CH3 also has an environment of CH2, both will form 1. And this CH2 and this CH2 are same, they will form 2. There will be 2 peaks only. And in this case, this CH3 and this CH3 are same, so they will form, all the 3 CH3 are same. All 3 are same, they will form only 1 peak, and 1 for OH, 2 peaks. Only compound which is forming 3 peaks is A. The answer is A for question number 39. Question 39, answer A. And the last question, question 40. A student performs an investigation to determine the content of ethanoic acid in vinegar samples using a non-standardized sodium hydroxide solution. The solution is non-standardized. Which type of error will occur and how will this affect quality of data obtained? Now, since it's a non-standardized solution, it means it is an error which is a systematic error. It is in the process, there is an error in the process, it's systematic. And systematic errors, they will be always repeated. How will that affect the quality of the data? Since it is a systematic error, it will not give an accurate result. Thus, the answer should be a systematic error and low accuracy in the results. Question 40, answer A. Systematic error and low accuracy should be answered. So that's all about question number 40. Answer is A, and we had completed the paper. All option done, all question done. Thank you for watching the video. Thank you very much.